Hello and welcome to our video. Today we are students from the University of Technology Malaysia would like to present to you the title of Humidification from our syllabus of separation process. First of all, we need to learn what is humidification. Humidification is the transfer of water from the liquid phase into a gaseous mixture of air and water vapor. With humidification comes dehumidification. What is dehumidification? Dehumidification is water vapor is transferred from the vapor state to the liquid state. Next, we want to know what is humidification process. Humidification process is the process in which the moisture or water vapor or humidity is added to the air without changing its dry bulk temperature. It's called as humidification process. This process is represented by a straight vertical line on the psychrometric chart starting from the initial value of relative humidity, extending upwards and ending at the final value of the relative humidity. In actual practice, the pure humidification process is not possible, since the humidification is always accompanied by cooling or heating of the air. Humidification process, along with cooling or heating, is used in a number of air conditioning applications. And now, we want to know the function of humidification. What is actually the function of humidification? Cooling and humidification process is one of the most used air conditioning applications for the cooling purpose. In this process, the moisture is added to the air by passing it over the stream or spray of water, which is at a temperature lower than the dry bulk temperature of the air. When the ordinary air passes over the stream of water, the particles of water present within the stream stands to get evaporated by giving up the heat to the stream. The evaporated water is absorbed by the air, so its moisture content, thus the humidity increases. One of the devices of humidification is a cooling tower. Since the main purpose of this video is to introduce you to the cooling towers, we must first know the cooling and humidification process. Cooling and humidification process is one of the most used air conditioning applications for the cooling purposes. In this process, the moisture is added to the air by passing it over the stream of spray of water, which is at a temperature lower than the dry bulk temperature of the air. When the ordinary air passes over the stream of water, the particles of water present within the stream tend to get evaporated by giving up the heat to the stream. The evaporated water is absorbed by the air, so its moisture content, thus the humidity increases. At the same time, since the temperature of the absorbed moisture is less than the dry bulk temperature of the air, there is reduction in the overall temperature of the air. Since the heat is released in the stream or spray of water, its temperature increases.
The engineering device that is used in the humidification process is the cooling tower. So, what are cooling towers? A cooling tower is a specialized heat exchanger in which air and water are brought into direct contact with each other in order to reduce the water's temperature. As this occurs, a small volume of water is evaporated, reducing the temperature of the water being circulated through the tower. So there are two types of cooling towers. The first one is the cross-flow cooling tower, and the second one is the counter-flow cooling tower. As you can see, here is the basic operation of the two types of the cooling towers. Now, we will dive in deeper on how these two different types of cooling towers operate. In cross-flow cooling towers, the water flows vertically through the fill, while the air flows horizontally across the flow of the falling water. Because of this, air does not have to pass through the distribution system, permitting the use of rapidly flow hot water distribution basins mounted at the top of the unit above the fill. These basins are universally applied to all cross-flow towers. In counterflow towers, They are designed so that air flows vertically upwards, counter to the flow of falling water in the field. Because of this vertical airflow, it is not possible to use the open, gravity flow basins typical in cross-flow designs. Instead, counterflow towers use pressurized, pipe-type spray systems to spray water onto the top of the field. Since air must be able to pass through the spray system, the pipes and nozzles must be further apart so as not to restrict the airflow.
Moving on to how cooling tower operates. Since a cooling tower is purposed to cool down the temperature of hot water, so it requires an amount of cool air. In the diagram here, the dashed lines are referring to the air, while the straight lines are referring to the water. Cool air will flow upwards while warm water passes down. Warm water flows countercurrently to an air stream. This will cause the heat transfer to occur. Water will then can be discharged to river or reused. The whole process is adiabatic. Here is an illustration that may help you to understand more about how cooling tower operates. Cool air and hot water will enter and flow countercurrently, and heat transfer will occur, leaving air with a high temperature out and resulting a cool water to exit.
Okay, next is the example of the processes that use the cooling tower. Okay, this is the common industries that use the cooling tower system. Okay, I have list down 4 of the common industries that use the cooling tower system. Okay, for the first one is food processing plant. Second one is petroleum refineries. The third one is natural gas plant. And the fourth one is the petrochemical plants. Okay, Okay, for the next slide is the others industrial applications. So I have list down 8 others industrial applications other than the common industrial. Okay, so for the first one is water cool air compressor. For the second one is plastic injection and blow molding machines. For the third one is die casting machine. And for the fourth one is refrigeration and chilling plant. And the fifth is cold storage. And the sixth is the anodizing processes plant. And for the seventh one is the electrical power generation plant. For the eighth one is the water cool air conditioning system and vent machines. Okay, so we can see these are the example of the picture is the example of the cooling tower system. Okay, that's all for our group. Thank you.